So yeah, thank you for the kind introduction. I'm going to talk about coordinated online behavior. So without further ado, what is coordinated online behavior? By talking about coordinated online behavior, we refer to groups of users that are performing synergic actions in pursuit of a common intent. There are many examples of coordination in social media and online social networks. Some of them are related to neutral or even benign activities, but some are also related to malicious activities. So for example, we know that the perpetrators of disinformation campaigns must be organized somehow to spread their messages and to have an impact. And this is a common example of coordinated online behavior, clearly a malicious one. We also know that there are groups that perform coordinated harassments. So again, another malicious example of online coordination. But at the same time, we also know that there are groups who are using social media to, let's say, support their protests. So which are people genuinely interested in some topics that are coordinated online to support their protests. We know that there's very big fandoms, for example, of some music groups, pop bands, and so on and so forth. And again, they're coordinated online because of their genuine interest in something, in a topic, something that they love. So what I would like to stress here is that coordination is not necessarily bad, okay? And throughout all of my talk, I will try to keep this in mind and to show ways in which we can detect both malicious and neutral or benign coordination, but also provide some tools for distinguishing between the two kinds, right? So since coordination can be bad and sometimes is actually bad, there's a great interest in platforms about detecting and characterizing and investigating this kind of coordination. And yeah, so I would like to give a brief overview of my recent results in this direction. So before going into the details and the technicalities, I wanted to spend a little bit of time also discussing what coordination is not. And I would like to start from this definition, which was perhaps the first account of the term, which dates back to 2018. And it is Facebook definition of coordinated inauthentic behavior. This is how the term was spread initially. So in this definition, there's a clear negative connotation, right, to coordination. But what I would like to stress out is that even if coordination and inauthenticity often appear together, those are two different concepts, okay? So coordination does not necessarily imply inauthenticity, and we will see it in this talk. And by, let's say, broadening this intuition, we could also say that coordination does not necessarily imply harmfulness. It can, but not necessarily, not always. Same goes for coordination and automation. Social bots, so automated accounts, surely coordinate between one another, but coordination is a much broader concept than that. So by coordination, we do not imply automation. And finally, coordination doesn't even necessarily imply a binary concept. So the view where let's say, social media accounts are either coordinated or not coordinated, that's a very simplistic view. And I would like to try and surpass this view and give a more nuanced operationalization of the concept of online coordination. Okay, so given this very brief introduction, let's jump right onto the methods, let's say. Now, there are different frameworks for surfacing, detecting, and studying coordinated online behaviors. I will focus on a branch of work which is based on network science. And specifically, in 2021, there have been actually 3 different groups that independently published their own methods for detecting coordinated online behavior, pretty much at the same time. 2 of them were published exactly at the same conference. I will focus on our work, clearly, but I would like to remark that there are very small differences between all of these 3 methods. So the basic idea is the same for all 3, which is kind of nice, since we all came up independently with these ideas. And the last method about Weber and Neumann also has an implementation which is publicly available. So if one wants to, let's say, start working with this, that could be a nice starting point. Okay, so basically all of these 3 methods could be somehow summarized with the 6 steps that I'm showing in this slide right here. And the initial step is surely the selection of a starting set of users that one wants to analyze. This is because of several reasons. So first of all, clearly, when we make an analysis, we're typically interested in a topic or in an event. And so we have to select some users that are related to that event. That's clearly one of the reasons. Another reason is that since, as I said, all of these methods are based on network science, you end up with pretty much big networks. And so for analyzing the network and sometimes even for visualizing these networks, you need to filter somehow, okay? So selecting, let's say, a focused starting set of users can be a first way of, let's say, keeping the size of the network under control. So one could, for example, focus on the users who produced the majority of content about a certain topic, like a national election, clearly the online debate of a national election, and so on and so forth. Or, I mean, any other way of selecting a starting set of users. Then the core part of all of these methods is actually step 2. Step 2 is based on selecting a similarity measure with which to compare the users. Now, this is important because similarity between users is used in these frameworks as a proxy for coordination. So a high behavioral similarity means that 2 users are likely to be coordinated between one another. And by similarity, I mean, for example, the possibility to quantify the extent to which different users tweet, for example, or post similar messages through time, so repeatedly through time, or even the possibility for different users to repeatedly retweet the same tweets almost at the same time, and so on and so forth. So basically, there are many ways in which we can compute similarities between users, but the core concept is that repeated similar behaviors which occur almost at the same time are a strong signal for coordination. And so whatever the metric we want to use, the measure we want to use, it has to be something that captures these concepts. Once we have our similarity measure, we can compute similarities between the pairs of users, which clearly gives us the possibility to build user similarity networks, okay? Where these are weighted undirected networks, where the edge weights are actually, as I said, proportional to the amount of coordination that we consider to be between any 2 users. As I said before, such networks are typically must be filtered somehow because the network is simply too big. And then what we are really interested in is coordinated communities. So we run community detection algorithms here. So the end result, let's say, after step 5, is a set of communities which correspond to different groups of users that are coordinated between one another. And clearly, what we might want to do after that is simply to make sense of what these communities are doing, what these coordinated groups of users are doing. So analyzing them, investigating them, characterizing them, and so on and so forth. And I can give some examples. So based on this, let's say, high-level overview right here, I would like to jump into some examples. And specifically, I will show you some results that we obtained by the application of this method to 2 online debates which are related to the UK 2019 and the USA 2020 elections. So starting from the UK 2019 general elections, this is the output that our method produces. We can see that there are different communities in this network which are related to the main coordinated groups of users that took part in the Twitter debate about the UK 2019 general election. Each community is color-coded. Let's take a look at the main communities that appear in this network. So clearly, we have 2 big communities of laborists and conservatives, the red one and the blue one, which were the main parties involved in the election. Nothing surprising here. We have this small green community right here. These are conservative users, which their main focus is not on supporting the Conservative Party, but rather they're focused on attacking the Labourist Party. That's why they're separated from the main community of conservatives. We have 2 other big communities TVT and SMP, the orange one and the yellow colored one, which are related to other parties involved in the election. Specifically, these are tactical voters, so-called tactical voters, which were a bunch of parties that teamed up with the Labourists and against the Conservatives. And then we have the Scottish independentists right here. And finally, we have two interesting communities, the small purple-colored community right here and the brown-colored community right here. These are not related to parties involved in the election, but rather they are activists that are protesting against unfair taxations, let's say, against unfair laws, which leverage the electoral debate to draw attention to their protests, okay? So these are the main coordinated groups of users. Now, another interesting thing that I would like to focus on in this slide is the fact that not only do we have communities which have different colors, but also the nodes, the users within any given community have different shades of color. So we have, for example, for the Labourists community right here, we have some dark colored users. And in the periphery of the network, we have, in the periphery of the community, we have some other lightly colored users. Now, this is because our method is able to compute a coordination score for each user, which is based on the edge weights that every user has. So we're not only able to see, let's say, the different coordinated groups of users, but also which users are most coordinated within each group. And so we can see, for example, we can start seeing some differences between the communities here, because the Labourist community and also the Conservative one have a core of strongly coordinated users and the periphery of lightly coordinated users. While, for example, if we take a look at the Scottish independentists and the tactical voters, we can see that they also have some strongly coordinated users, which are dark colored, but they do not form a core of users in this community. The strongly coordinated users in SMP and TVT are spread out and scattered throughout the community, which gives us an idea of a much less organized and much less coordinated community. And finally, we have the opposite scenario. For example, LCH, where almost all of the users are extremely coordinated between one another. The community is very dense and compact, okay? So what we can do here is to try and quantify some of these assessments, okay? And our approach was to come up with a set of measures, a set of indicators. Some are based on the network structure of the community and of the network in general. And this can be useful for understanding the patterns of coordination, the different patterns of coordination that each community has. And we also used some other indicators which are possibly related to the inauthenticity or the harmfulness of the communities. So for example, we computed automation scores. So the likelihood for any account to make use of automation, let's say, which can be a proxy for inauthenticity. We checked Twitter suspensions of those accounts, which clearly is a strong proxy for harmfulness, and also propaganda scores, which are all indicators that can give us an idea of the activity of each coordinated group of users. And now, the interesting part is that for each of these indicators, and I'm starting to show something about the, let's say, the network properties of these communities. But for each of these indicators, we can actually analyze the indicator throughout all the continuous spectrum of coordination. Meaning that, for example, when we consider coordination in the region of 0.8, for instance, we are only considering this indicator for the users who are coordinated with a score which is higher than 0.8 on a 0 to 1 scale, okay? So we are only considering, let's say, the most coordinated users when we look at this portion of the plot, and the slightly coordinated users when we look at this portion of the plot right here. So this plot right here shows the amount of users at each degree of coordination. And we can start seeing some very big differences, because, for example, this community right here, the brown one, which was one of the activists which were protesting against unfair taxation, almost all of the users in this community are strongly coordinated, because we see that the size of the community doesn't change until very high level of coordination. while instead some other communities have a much different, let's say, feature a much different trend. Now we can repeat the same analysis for a number of other network indicators, which, as I said, can give us an idea of the patterns of coordination of this community. So, for example, if we focus on the orange community right here, we can see that these users have a decreasing clustering coefficient when we consider the most coordinated ones. And this gives us, again, the idea that the most coordinated users in this community are not really organized, well organized, and the activities of these communities are not orchestrated, let's say. While on the contrary, the purple one community shows this steeply increasing trend in clustering coefficient, and the same goes for density, if we look at that, which reinforces instead the idea of a very strongly coordinated community. Now, we can do the same about a number of other indicators. For example, here we have automation, suspensions, and propaganda. And again, we can see some interesting trends. So for example, the purple community has this decreasing trend of suspensions when we consider increasing levels of coordination, meaning that the most coordinated users in this community are unlikely to do anything harmful, okay? Which again reinforces the idea that this community is a harmless one. And the green one instead has, again, a very different trend. The same goes for propaganda. So for example, the purple community has this decreasing propaganda trend, while the green community has this increasing propaganda trend. So all of these things taken together can give us interesting insights into the nature of this community, into the activities of this community, okay? Now, one thing that I would like to draw your attention to is the difference between studying coordination, let's say, in a binary fashion or in a more nuanced fashion. What I just showed you is clearly a nuanced approach to the study of coordination. And I would like to give you some or let's say a counterexample of what happens if we study it in a binary way. Many approaches actually study it in a binary way. So they make a crisp distinction between coordinated and non-coordinated users. And they do that by dropping all edges in the network, which are below a certain arbitrarily fixed threshold of edge weight. So one common value is this 0.9 edge weight. Everything, all the edges whose weight is lower than 0.9 are dropped, and all the disconnected nodes are dropped as well. And this is the edge weight distribution in our network, and you can see that almost no edges have a weight which is larger than that. So by applying these very restrictive and arbitrary thresholds, you risk discarding some very important and some very meaningful network structures, which is not what we do, okay? We apply a statistically, let's say, the statistical backbone of the network we compute, which basically means that we retain only the statistically significant edges independently on their weight, okay? And so, as I said, by doing this, we retain all network structures that are statistically significant, not only those related to heavy weights, let's say, to large network weights, but all of them, which are statistically significant. And if we applied this threshold-based filtering to our network, what we would obtain is something like this. So depending clearly on the threshold that we apply, we can filter more or less. But the point here, my point here is that you can never get something as nuanced as this network right here with the different levels of coordination for each user and so on and so forth if we apply a binary model of coordination. So I advise against seeing coordination as a binary concept, and I advise in favor of, let's say, keeping a more nuanced approach to the analysis of online coordination. Now I would like to show you some other results, those related to the USA 2020 presidential election. Similar approach as before, so the method is the same. Let's take a quick look at some of these communities. And I grouped actually the coordinated communities in three meta clusters, if we could say like that. So again, we have the two main parties involved in the election, so Democrats and Republicans. You can see that they they appear here in the network, and this is the only cluster of Democrats user in the whole network. So all other communities are somehow supporting Donald Trump and the Republican Party, okay? So the only community of Democrats is this one right here, which, as you can see, is also, let's say, detached from the others, okay? This is already striking because we are looking at the most coordinated users. So basically all of the coordinated users in the Twitter debate about the USA 2020 presidential election were in favor of Donald Trump and the Republicans. Okay, so apart from the main community of Republican users, what else do we have here? We have 4 different groups of coordinated users that are conspiracy theorists, basically. And we can see a bunch of different, let's say, types of conspiracy theories, going from users that were supporting the idea of conspiracies as part of the COVID-19 pandemic. We have QAnon supporters, and we have others that are related to election fraud. So quite a bunch of different conspiracy theorists here. And then, interestingly, we also have 4 communities of coordinated users that are related to some kind of foreign influence in the election. So, for example, we have Iranian and Nigerian and French and Hong Kong supporters of Donald Trump. And all of these communities are actually, again, leveraging the election to draw attention to their own agendas, okay? We will see this in a bit more detail in a while. So again, what we did, as in the UK 2019 example, we computed a bunch of measures, okay, to try and characterize the activity of these communities. Something is similar to what we did before. So for example, automation and suspensions. But this time we also wanted to quantify partisanship. So how politically biased is a community? And we used these media bias, fact check, political bias scores, and also the degree of factuality of the community. So meaning to what extent the users in a community consume and share factual news, okay? And again, we leverage the media bias fact check, factual reporting scores. This time, what we did was to come up with this idea of community cards. So these kind of radar plots, which show all of the indicators that we are considering with these star-shaped plots. And by the shape of the stars, we can understand the nature of these communities. So these are the 2 main communities related to the 2 main political parties involved in the election, Republicans and Democrats. And you can clearly see that, first of all, the stars are quite small. So none of the indicators that we considered reaches, let's say, extreme levels, which is a good sign, let's say. We can note that, for example, the Democrats received almost no suspensions at all. They do not have strong coordination, and so on and so forth. The Republicans are a little bit more suspicious because, for example, they share much more non-factual news. But I mean, apart from this, the situation looks quite normal, let's say. Let's take a look instead at the conspiracy theorists. We have a much different situation. You can see, for example, the degree of suspension for some of these communities, which is huge. And we can see that these Republican conspiracy theorists, these probably are the, let's say, the most harmful community out of all the online debate. They have extreme levels of all of the indicators that we considered. So this is a community that should be taken into account seriously. And then we have these other communities which are related to this kind of foreign influence, as I said. And here the situation is much more diverse. So you have some communities that appear to be suspicious because they are, let's say, they rank high according to some indicators, but they received no suspensions at all. Like these Hong Kong protesters, which are pushing narratives against China, for example. And these Biafra independentists, which is a region of Nigeria. And again, they are kind of supporting the Donald Trump as a way to draw attention to their issues. So again, this view, I think it gives the idea of the kind of insights that you can draw about the coordinated groups of users. Okay, I would like to conclude my talk by introducing another more recent direction of research that we took, which again provides an example of how we can embrace the complexity of this phenomenon, okay, when we study online coordination. We talked about the difference between between binary and nuanced approaches to the study of online coordination. Here we make a similar distinction between static and dynamic analysis of coordination. So clearly, coordinated online behavior emerges as a consequence of human behaviors, right, on the social networks. And the human behaviors are dynamic, meaning that they are time varying. They change through time. However, all of the things that I showed you until now are based on static analysis. So let's assume that you have 1 month of data, 6 months of data, you name it. You aggregate all of that data and you come up with a single network that, aggregates all of the information that you have in your data set. However, we could take a different approach. We could try and see the evolution of this network through time. And the way in which we did it, the way in which we went in this, let's say, more dynamic direction, is by considering some fixed length time windows, for example, 1 week of data only, and coming up with a network which is similar to this one, but by only considering the first week of data. And then we move this time window with a kind of overlap with the previous one until we have consumed all of the data, all of the time span covered in our data set, which yields a multiplex temporal network. So for each time window, we have a snapshot, let's say, of the network. And what we can do is not only to have connections between nodes in the same snapshot, but also connection between the same node, let's say, which appears in different snapshots through time, okay? Which makes it a multiplex network. And then we could apply some community detection algorithms that are based on multiplex network. And this gives us the possibility to study, for example, how a single user changed its membership to different coordinated communities through time. Also, how different communities expanded or shrank through time, okay? So the whole evolution of these patterns of coordination through time. This is exactly what we did. So some of the results here are, for example, related to the stability of the coordinated communities. So how coordinated communities stable through time? One way in which we can see this is by checking their size, clearly, right? And we can see, for example, that if we compare the size at any given time with the initial size of the community, the size at time 0, let's say, we can see that there are some very different, let's say, dynamic evolutions of these networks. So some networks actually expand tremendously at certain points in time, becoming also twice the size of the initial community, while others shrank. And while some almost constantly increase their size throughout all of the time, like this, let's say, greenish one or whatever color this is, others almost continuously shrank through time, like this pink one right here. So again, there are some differences. And the fact that some communities experience some huge changes shows why aggregating everything might not be the best idea, right? Another way in which we measure stability was by comparing the set of users who are members of a community at any given point in time with the initial set of users for the same community. And we can see that there are some communities who have a rather stable membership, so meaning that the users that belong to that community do not change much through time, while other communities instead almost change their members completely, okay? And then we computed a bunch of other things that in the interest of time I'm not showing now. But what I would like to show is that, in the previous slide, we saw that different communities had different temporal behaviors, different temporal dynamics. These temporal behaviors and dynamics are due to the behavior of the users, right? So we went on to analyze the behaviors of the users. And we saw that, for example, 49% of the users belong to one single community for all the time. So they are completely stable, let's say, stationary. But this means that 51% of the users actually belonged to more than one community. And since the user behaviors, which we see as these marginal distributions right here, since they follow heavy tail distributions, we know that there is a minority of users who is extremely volatile, so who changes community very often, while the bulk of the users never changes. And we also know that all of the, let's say, different behaviors in between the stationary and volatile extremes are also represented in the data, okay? So this gives us interesting information about the behavior of the users, and I'll get back to this in a while. But something else that we did was to consider the political polarization of the communities. So we can come up with a polarization score for each community based on the content, for example, that they share or the news that they share. We clearly have laborists going to the left and conservative communities going to the right, and some communities in between. I'm talking about something that I did not mention is this analysis is about the UK 2019 dataset again, okay? So we have the laborists and conservatives. And what we did again was to kind of see users that are changing community. What is the origin and destination communities of their shifts, of the changes that they made? And we can see that the majority of changes occur between similar communities, right? So politically aligned ones. But however, there's a minority of users who actually crossed the whole political spectrum, shifting from the most conservative community in the dataset to one of the most laborists one, okay? Which is interesting. So it could be interesting to dig deeper and analyze why this user changed completely, let's say, their political orientation through the course of the electoral debate. And another interesting thing that we noticed here is that the majority of shifts occurs towards the left of the political spectrum. So if you can see, the majority of shifts goes to the left, which means that the left-leaning communities were able to attract more users than the right ones, okay? Or we could say differently, that the overall political ideology of the users in the network tended gradually to shift towards the left as the electoral debate unfolded, which is an interesting finding, I think. Finally, as I said before, since user behaviors are, let's say, they follow heavy tail distributions, we know that there are a bulk of stationary users who never change community. We know that there is, let's say, a minority of extremely volatile users who continuously change. And we also measured that there are a number of users which we called influenced, which changed community at a certain point in time and then remained in their destination community throughout all of the remaining time, okay? So they changed once and they stayed in the destination community. And what we wanted to do is we tried to characterize how these different types of users, let's say, were present in the coordinated communities that we had here. And we found some interesting things. For example, moderate communities experience less variation in size and membership, and they also contain the majority of stationary users, as you can see here. So moderate communities appear to be more stable than highly polarized ones. And another interesting finding is that right-leaning communities in this debate appear to be, again, more volatile than the left-leaning ones, because you can see, for example, that the share of volatile users, orange, is much higher in the right-leaning communities than in the left ones, while instead the left-leaning ones have this higher share of influenced users, so users who joined and stayed here. Okay, so some interesting insights into the study of, or perhaps the interplay between political ideology and online coordination in a dynamic setting, let's say. Okay, so to wrap up and to conclude, I think that the study of coordinated behavior is quite recent, and so there's still much work to do. And as such, there are a number of challenges that we need to still overcome. Part of these challenges are technical. So for example, the analysis of dynamic coordination, or also the possibility to leverage multiple signals to measure coordination. So some technical challenges, let's say. But we also have some philosophical challenges or some conceptual challenges. So for example, what is really harmful? How can we really understand and label if a certain if the activity of a certain coordinated community is harmful or not? There are some controversial examples. For example, perhaps some of you know the story about the teens on TikTok, K-pop fans on TikTok, who booked a lot of seats for a Trump rally in Tulsa, and they never showed up to the rally. So they actually reserved and then, let's say, they did not make use of the reservation in an effort to clearly spoil the rally. They did that by organizing on TikTok, and this was not considered an example of coordinated inauthentic behavior or coordinated harmful behavior. But clearly this is controversial. I think the organizers of the Trump rally would have liked a different outcome, let's say here, a different evaluation. So it's not easy to put a label, let's say, on a community and say that its behaviors are harmful or otherwise. And that's why we took this approach where we considered a large number of different indicators to make sense, to look at them and make sense of what the community does. But still, we need, I think, to do more in this direction and investigate which behaviors can be considered to be harmful and which harmless. And regarding future directions, all of the things that I showed you basically are descriptive analysis, right? So post-hoc descriptive analysis. What we would like to do is to go in the direction of some predictive analysis. So turn some of the things that we saw here, in a predictive way. And for example, I think this could be very interesting when we consider dynamic coordination, because, for example, we have the possibility to draw insights into the patterns of influence and persuasion online. So, for example, we can try to predict when a user will shift from a community to another. So when he will abandon a community and join another community, if the user will do this, when it will do it, to which community he will go, so which community he will join, let's say, and possibly even why, possibly even understand what are the drivers for these kinds of user behaviors. And I think all of this received limited attention until now, so this could be interesting to explore in the future. This pretty much concludes my presentation. I would like to thank all of my collaborators that helped me achieve these results, and also you for bearing with me for this time. Thank you.
Thank you. Questions in the room? Any questions? Or please use the hands tool in Zoom if you want to have if you want to ask anything. I have questions. Several actually. So the plot that you showed on election 2020, that strikes to me Democratic volume versus Republican. So I wonder if these plots have like in terms of reach of when I say reach, I mean how much people are reading this information. They are a little, in a way, correct me if I'm wrong, but they seem a little misleading, right? For the reach. I know it's not the intent, no, but would it be useful? I don't know. So some sort of visualization, because this sounds like very few users had like a lot of influence in terms of Democratic, or it could be that the mobilization in the Democratic side was much lower. So this kind of plot doesn't allow you to see that. Not sure if you thought about this.
Yeah, I totally agree with you. I think that this is not taken into account in this analysis. So I would not make any claim about the reach or about the influence of these communities over others on the network. What we can see here, I think, is the degree of organization of the different communities. So we could, what I think we can conclude is that Republicans are more organized and more coordinated than the Democrats here. Now, this does not necessarily imply that they have a stronger reach or a stronger influence, but it tells us something about the way in which they are leveraging social media to pursue their objectives, let's say. I don't know whether this answered your question.
Yeah, it does. And then the follow-up, but it's not a question, more of a comment. It would be interesting to see the comparison of this plot with the previous election. Okay, so where across elections, so does like results and strategies have to do with like how this plot looks like? And very likely yes, but I'm not sure if you look at that. Second question I had is on.
If I may, I totally agree with you, and that's exactly the direction in which we are trying to go. Also with the dynamic analysis, right? So we have some before and after snapshots, and we are really interested at evaluating how things change through time, which I think is even more interesting than these, let's say, fixed snapshots.
And yeah, I think you were answering as I was typing notes for the questions. So you introduced this dynamic analysis, because to me, inauthentic behavior, or not necessarily harmful, I agree with you on that, has to do with bootstrapping as well. Bootstrapping meaning that in industry we are kind of worried about this kind of coordination, robotic coordination that is bootstrapped and then goes viral afterwards. So there's like a mixture of automation versus organic, which I think your dynamic analysis, I think you didn't focus on that, right? Not sure if you looked at that, but I think that would be really interesting in understanding, do we have this type of communities that are bootstrapped and then let alone, and then they kind of hide that kind of maybe harm or coordination out bot, you call it bot, I don't know, the metric for the bots. So did you analyze this? Is this happening, like this bootstrapping phenomena?
I think this is super interesting, actually. We did not explicitly take this into account. This was our first work about the, let's say, dynamic approach to the study of online coordination. But I think this is super interesting. And it also relates to, let's say, the different types of coordinated communities that exist. Because as you said, you could have, let's say, bottom-up activities to coordinate users, or you could have some top-down forms of coordination where you have some hubs and a lot of different, let's say, accounts, whatever their nature, automated or otherwise, that could be kind of following the hubs and kind of coordinating to support the activity of the hubs. We tried to give some insights into this by looking at the structural patterns of these communities. So, for example, we took a look at assortativity, for example, to realize whether the most coordinated users in a network appear to be peers, so equal, let's say, users who genuinely coordinate between one another because of a common interest, for example, or whether the network and some communities were extremely disassortative, meaning that you had really some hubs which were extremely important and a bunch of, let's say, less important, less prominent accounts that were supporting the hubs. And we noticed some striking differences. But yeah, we did not consider the fact that some, for example, automation could be used to bootstrap certain activities at a certain point in time, and then when they go viral, other users are doing this. Yeah, but I think this is.
Yeah, I'm asking this because the community cards that you showed, I think when looking at that, I was thinking, okay, maybe this is averaged, so in the sense that organic users are milding down the extremes here, right? Versus if you look at that over time, it might be that kind of shape goes from super radical to milding down, and as the average kind of milds it down. So maybe that would be like an interesting thing to analyze if you haven't done it.
Yeah, we did not combine these community cards, which were part of the static analysis, with the dynamic ones that we did afterwards. But that's a tremendous suggestion. So thank you.
Awesome, Haris. One more question.
Hi, Stefano. This was extremely interesting. This is Aris.
Hi, Aris.
Hi. I have two questions. The first one is with respect to your framework. The first two steps that you saw was filtering for the users and defining a similarity measure to create your network, essentially. Do you have a sense of how sensitive is your method to these steps? If I can think of many ways to define similarity measures. So if I take one or the other, what would be the what would be the impact in your method?
Yeah, I think you touched a very interesting point, Aris. I think the second step is particularly important here. Also because this is the only way, actually, in this framework, this is the only way in which you can model the coordinated activities between the users. So, for example, if you have users who coordinate based on retweets and your metric captures this, your network is informative, okay? But for example, you can have many different patterns of coordination between users. And if you use a metric that doesn't encode the type of coordinated activities that the users perform, then you end up with a network which provides very limited information, right? So this actually allows me to talk about another future direction, which for time reasons I did not mention, which is the use of multiplex network, not in a temporal sense, but in the sense of simultaneously considering different possible types of coordinated activities between the users. So you could have one layer where you consider, for example, the content similarity, however you want to measure it. Another layer in the network where you measure the similarity between the interactions among the users, and another where you have another metric. And this can allow to simultaneously consider, let's say, an array of possibilities regarding to the coordination of the users. So yeah, I think step 2 is particularly crucial here to have informative networks.
Can I ask the second question? Okay, could be. Okay, Stefano. So for my second question, so we saw several examples of what you call coordinated activities with election, the groups, and so on. Have you looked at any control data sets that there was some genuine viral discussion? Let's say Shakira released her latest song, people start talking about that. So this was just fans talking about some viral content. So can you distinguish between these two types of events?
So we did not apply these methods to, let's say, non-polarized discussions, if I may call it like that, non-controversial discussions. We always applied them to some topics where you might expect some degree of polarization, of controversy to show up. So the short answer to your question is no, we did not look into this. What, however, we noticed is that, as you can see, we found some communities that took part to an electoral debate, but with, let's say, objectives that were completely different with respect to all of the other users in the network. So here we have, for example, the brown and the purple community has nothing to do with the election, especially this community right here. These are females, these are women that are protesting against an unfair taxation that penalizes women born in the 50s in the UK. So they have really nothing to do, let's say, with the election. They are, protesters, let's say, who wanted to draw attention to their cause by, let's say, leveraging the electoral debate. And I think, I mean, this community right here has some very peculiar characteristics when we analyze it. It is different from many of the other communities. So I think that this approach can provide information for distinguishing between, let's say, different forms of online activity and different forms of online coordination. So although it has not been the focus of our work. I think it is possible to differentiate between these kinds of activities, these kinds of behaviors.